Let's sketch out this circle. And we're told that it has center 0, 0. So I'll put the axes here. And then the line L intersects it at the point P and Q. Coordinates of P are 5, 10. And Q minus 2. Minus 2, but we don't know the y value here, so I'm just going to write y. Now what we can do in this situation is work out the radius, because I can connect the center up to that point, and I've created a right angled triangle. It goes along 5 and up 10, and this is the radius. So using Pythagoras, because that's a right angle, r squared is going to be 5 squared plus 10 squared, which is 125. So r will be the square root of 125, which is root 25 times 5, or root 25 root 5, which gives me 5 root 5. Maybe it's best to leave it as root 125. We'll see later on. Alternative way of thinking about this is the equation of a circle centre of the origin is x squared plus y squared equals r squared, for the similar sort of reason. For any value of x here and y here for my coordinate, x squared plus y squared will equal the radius squared. I can draw a triangle over here. It will still give me x squared plus y squared is r squared. So what we can now do is draw another triangle going down to here. But this time I know the radius is root 125. Let me write it like that rather than 5 root 5. And then this length is going to be 2, so I can work out the y value. Y is going to equal, this time, root 125 squared, which is 125, minus 2 squared, which is 4, square rooted. Technically, I need a plus or minus in here, because I'm not just applying Pythagoras' theorem to find a length now. I'm actually, there's going to be two different values that would give me a x coordinate of minus 2, actually. So I'm looking for the negative y value, so I definitely need that negative in there. It's going to be plus or minus root 121, which is 11, and I'm going to take the negative. So this here is minus 11. Okay, so that's halfway through the question. Just going to remove some of this now. So we have worked out the coordinate of Q. Okay, at this point I'm going to bring in the line. If I brought it in too soon, I think it would have got a bit messy, but I can join it up here. And of course, it's going to extend and carry on and extend the other way as well, like that. Okay, and we want to find the value of K. That's this here. We're expecting it to be negative. So what do we know? Well, we know we've got 2 points, so we can find the equation of the line. M is going to be y2 minus y1, or you might say 10 minus 11. Okay, we're going up by 21, and we're going along from minus 2 to 5. We're going along 7. You could alternatively just write 10 minus 11 over 5 minus 2. That's our y2 minus y1 over x2 minus x1. But we get 21 over 7, so we get 3. Then y is going to equal 3x plus c, which in this case is actually k. I'm just going to write that in. And now I can sub in one of the points. So let's just backtrack. We used P to work out the radius of the circle. I then used that in Q to work out the y coordinates. And then I connected them together and turned this question into find the equation between 2 points, with the main aim being to find the y-intercept. We found the gradient. We're now just using that to help us find the y-intercept. So I'm going to sub in the 5 and the 10. It's just a bit easier than subbing in negatives. So 10 is going to equal 15 plus k. K is going to equal minus 5. Good effort.